Hello and welcome. Namaste. Time series analysis in statistics, and we are discussing the method of least square, fitting of linear trend and odd number of years. Now we are going to discuss a case in which we have interval of 5 years. We are actually studying some exceptional cases because generally the time series is preferably always with a gap or interval of 1 year only. But these are exceptional cases, but we need to study them. Yes, odd number of years, 1, 2, 3, 4, 5. So the origin will be the middle year. And in this case, origin is 2006. On the basis of which we can determine the variable x that represents the time factor, and time factor is the collective effect of all the factors influencing the phenomena we are interested in or we are studying. Origin, year minus origin, that means year minus 2006 divided by interval will be 5 in this case. If we find x value for the year 1996, it will be 1996 minus the origin 2006 divided by interval of 5, that will be 10 by 5 is equal to 2. Similarly, if we find value of variable x for the year 2001, it will be 2001 minus 2006 the origin divided by interval of 5, that is 5 by 5 is equal to 1, and so on. 1. So 2006 minus 2006 will be 0. 2011 minus 2006 positive 5 divided by 5, that will be positive 1, and similarly here positive 2. We need summation of both these things, both the variables y as well as x. Positive 3, negative 3, x must be 0, and in case of y it will be 11 plus 12, 23 plus 14, 37 plus 18, 55 plus 16, 71. Now as we know that we need the values of two more columns, or rather summations of two more columns x, y, that will be 11 into minus 2, minus 22, 12 into minus 1, minus 12, 14 into 0, 0, 18 into 1, 18, and 16 into 2, 32. The positive total is 18 plus 32, 50. Negative total is 22 plus 12, 34. So ultimately it is 16 sigma xy. We need one more thing, and that is x square. X square means squared value of all x values. Negative 2 square is 4, my negative 1 square is 1, 0, 1 and 4 again. So 5 plus y it will be 10 sigma x square. Now the relationship or linear relationship, the standard equation is y or y estimated or y cap or yc, many signs are used, equals to a plus bx. This is something like the line of regression of y on x, more or less, not more or less, actually both are similar. Yes. Now on the basis of this standard equation, we can have two normal equations according to the method of least squares, and first is summation of the variables in this case. So it will be sigma y equals to, now sigma with a constant value becomes n, so it will be na plus b sigma x. Let's substitute the values. Sigma y is 71, n is 5 and sigma x is 0. So ultimately it is 5a equals to 71, therefore a equals to 71 divided by 5, therefore a comes to 14.2. Now the another normal equation is just multiply this first normal equation by x. So it will be now sigma xy. Now we know that here n is actually sigma. So if we multiply this factor by x, it will be a into sigma x plus b into sigma x square. Now let's substitute the values. Sigma xy is 16, a into sigma x 0 plus b into sigma x square is 10. So this is 10b equals to 16, hence we can say that b is 1.6. What is b in this equation? What is b? b is the slope of the straight line. And another meaning of b is constant rate of change. Values, positive b means constant rate of increase, negative b means constant rate of decrease. Here b is positive, so this is constant rate of increase. Increase in what? Value of the variable. We believe that on the basis of this straight line relationship, we believe that every year the value of the variable increases by 1.6. Now let's substitute a and b in this standard equation. It will be y estimated equals to a plus bx. So y equals to 14.2 plus 1.6x. This is the straight line relationship or linear relationship between these two variables for this time series. Now this time let's we find the trend values. You can add the column of trend value to this table also. What do we mean by trend values? Trend values means estimated values of y for all the years given in the time series. Yes? Okay. So we just have to substitute all these x values into this equation. For the year 1996, estimated value for the year 1996 will be known as trend value for 1996 because 1996 is already the part of the time series. That's why we call it trend values. Otherwise, it is estimated value of y for that particular year. It will be 14.2 plus 1.6 into what is the value of x for 1996? It is minus 2. So it is 14.2 minus 3.2. So it comes to 11. Similarly, for the year 2001, it will be 14.2 plus 1.6 into minus 1. So it is 14.2 minus 1.6. So it is 12.6. Thus, the value of the variable increases by b every year. So now we can say that if we add b 1.6 to the previous trend value, we can have the trend value for the year 2006, and that will be 14.2, and the trend value for the year of origin is nothing, it is exactly equal to a, because in the year of origin the value of x is 0. So if we substitute 0 in the place of x in this relationship, the estimated value will be 14.2, that is trend value of base year or year of origin. Every time this will happen. Again add b to this trend value to have the trend value for 2011. That will be 14.2 plus 1.6, 15.8. Again add b to that trend value, so it will be 17.4. And now get the summation of trend values. It must be equal to or as near as possible to sigma y. This is a very small checkpoint for the students. So in this case we discussed the linear relationship between a variable for this time series where there are odd number of of years but with an interval of 5 years. I want to repeat that in real life generally the time series are having a gap of 1 year only, but in exceptional cases this kind of time series are possible. That's why I prefer to discuss this case. That's it. Thank you very much.